Hi dear, today we'll see activity 3.1 to 3.8. Okay, so what is the first activity? Take samples of iron, copper, aluminum and magnesium. Note the appearance of each sample. Okay, then clean the surface of each sample by rubbing them with the sandpaper and note their appearance. Okay, so what is that? So if you simply take this iron, copper and aluminum and magnesium, if you look at them, they have less shiny surface. Okay, it has less shiny surface. Once you rub with the sandpaper, then you can see that it becomes more shiny. Okay, why? Because these metals, this iron, copper, aluminum, magnesium are very reactive metals. They form a metal oxide, right? Metal oxide. So if you remove it becomes less shiny. If you remove that by using the sandpaper, then it becomes more shiny. Okay, so what is the conclusion from this activity? Metals in their pure state have a shining surface. Metals are shiny, metal has a shiny surface. Okay, this property is called metallic luster. Okay, this we'll call it as a metallic luster. Usually the metals will have shining surface. Okay, next activity 3.2. Take a small piece of iron, copper, aluminum and magnesium. Try to cut with these metals with a sharp knife and note your observation. Okay. Then hold a piece of sodium metal with a pair of tongs. Always this caution. Okay. Handle sodium metal with care. Dry it by pressing between the folds of a filter paper. Okay. So first we need to take iron, copper, magnesium and we'll try to cut them with the knife. Then we are going to take a piece of sodium and we'll make it dry by folding in a filter paper. Put it in a watch glass and try to cut it with a knife. What do you observe? Okay, so if you take the iron, aluminum and copper and all, they are very hard to cut. Okay, if you cut with a knife, it is very hard to cut. Okay, but in case of sodium, it can be cut easily. Okay, so what is your conclusion from this? Most of the metals are generally hard, and this hardness varies from metal to metal. Okay, even if you check with this iron, copper and aluminum, the hardness will vary. Okay, but when compared to all this thing, the sodium is very soft and it can be cut with a knife. Okay, usually metals are hard and it varies from metal to metal. That is the conclusion. Okay, in this activity. Next activity 3.3. So what is your activity 3.3? Take a piece of iron, zinc, lead and copper. Place any one metal on a block of iron and strike it 4 or 5 times with a hammer. What do you observe? Repeat with other metals. Record the changes in the shape of this metal. Okay, so if you take this iron, zinc, lead and started beating. Okay, beating, then you can observe that the metals can be beaten into thin sheet. When you keep on beating this metals, then this metal became a thin sheet. Okay, so what is your conclusion from this? Some metals can be beaten into thin sheet. This property is called malleability. Okay, if a metal is beaten into a thin sheet, that property of that metal is called malleability property. Okay, malleability. Okay, next activity 3.4. List the metal whose wires can be seen in daily life. Okay, so some of the metals can be drawn into wire, right? For example, iron, copper and aluminum. Okay, so what is that? If a metal is drawn into a wire, that property is called ductility. Okay, the ability of metal to be drawn into thin wires is called ductility. Okay, when it is beaten into thin sheet, it is called malleability. When it is drawn into a thin wire, it is called ductility. Okay, so one of the most ductile metal is the gold. Okay, gold. That means how can you say that? Means about 2 kilometer length can be drawn from 1 gram of gold. Okay, with the help of 1 gram of gold, we can draw this gold into thin wire, to which how much length? 2 kilometer length. Okay, next activity 3.5. So activity 3.5 is take a aluminum or copper wire, clamp clamp this wire on the stand as shown in the figure. So you are going to take a copper or aluminum wire, you are going to clamp this wire like this, okay, and at the fix a pin to the free end of the wire using the wax, okay. You are going to fix a pin here at the end of the wire using a wax, okay. Heat the wire with a spirit lamp, candle or burner near the place where it is clamped. Near the place where it is clamped, you are going to heat this wire, okay. What do you observe? Note your observation, okay. So when you heat this wire at this end, after some time this pin will fall, the wax will melt and the pin will fall down, okay. The wax it melts the wax and the pin drops, okay. And one more question, what do you observe after some time? The wax melts and the pin drops. Note your observation. Does the metal wire melt? Does the metal wire melt? No, the metal wire does not melt, okay, does not melt. That means what is your conclusion from this? Metals are good conductors of heat. This wire can conduct this heat, right? That's why when you are heating this wire at this place, it is passed to this place and it get heated and the wax melt. Once the wax is melt, the pin is hold on the wax, right? So the pin will drop down, okay. So it is a good conductor of heat. Does this metal wire melt? No, it will not melt because it has a high melting point, okay. It has a very high melting point. So what is your conclusion from that? Metals are good conductors of heat and have very high melting points, okay. Some of the best conductors of heat are silver and copper are best conductors of heat, and comparatively the lead and mercury are poor conductors. When compared with the silver and copper, it is poor conductor, okay, but it will conduct the heat, okay. Fine. Next, activity 3.6, set up an electric circuit. So you are going to set up an electric circuit like this. Place the metal to be tested in the circuit between the terminal A and B. You are going to keep the metal here between these terminals. Does the bulb glow? What does this indicate? So you are going to set up a circuit like this. Bulb is connected to the metal is going to connect. If it is a continuous wire, when you switch on, the bulb will glow, okay. Now we are going to cut the wire and we are going to place a metal here, okay. If it is a good conductor of electricity, then electricity will pass through this, right? So we'll check that, okay. So what is your observation? Yes, the bulb will glow. Yes, the bulb will glow. What does it indicate? It indicates that metals are good conductors of electricity. It indicates that metals are good conductors of electricity, okay. So one more question is with this part related with this activity. Why are electric wires coated with polyvinyl, or that means polyvinyl chloride, PVC pipe, or a rubber like structure? Okay, you know that this metal will conduct electricity, okay. If you touch this metal, then electricity will pass through your body, right? So that's why it is coated with the polyvinyl chloride or rubber, because these are insulators. This will not conduct electricity, okay. The flow of charges will not be there. PVC or rubber are insulators. They do not allow an electric current to pass through them. They do not allow the electric current to pass through them. Therefore, even if you come in contact with the wires, will not get a shock, okay, because the current will not pass through our body, okay. That's why even if you see the wire in your home, you will have a copper wires inside that. Over that you will have a PVC coating, right? Some of the coating will be there. Inside that you will have a wire. You will have a copper wire inside that. Usually they will cut this piece and this copper wire can be exposed like this, right? So that's why these wires are covered with the polyvinyl chloride or rubber like structure to prevent the shock, okay. Next activity is so from this activity 3.6 we have concluded that metals are good conductors of electricity, okay, fine. Next activity 3.7, collects these are all non-metals. Okay, so far we are saying about the activity with the metals, and this is non-metals. Collect samples of carbon. It may be either coal or graphite, sulfur and iodine. Carry out activities 3.1 to 3.4 and 3.6 with these non-metals and record your observation. Same. What are the activities we have done? So far we have done test the property, surface of the metals, and what is this, its hardness and its malleability property, ductility property, and conductivity property and all. Okay, so we are going to perform this one. So we are going to write the elements coal, graphite, sulfur and iodine, and symbol and type of surface, whether it is lustrous or not, and hardness, whether it is hard or not. Malleability means it can be beaten into sheets or not. Ductility means it can be drawn into wire, conduct electricity. And sonority. Sonority is nothing but the producing sound. When the things strike a hard surface, it should produce sound. Then it has sonorous property. Okay, metals usually have sonorous property. Okay, so we have elements. First one is graphite. It is represented by the symbol C, and coal represented by C, and sulfur again sulfur is represented by the symbol S, and iodine is I. Okay, these are the elements and symbols we are going to see. Okay, first we'll see the type of surface. Okay, type of surface. So you know that metals are lustrous in property, right? So here graphite is non-lustrous, coal is non-lustrous, and sulfur is non-lustrous, but iodine has lustrous property. Though it is a non-metal, it has a lustrous property. Okay, and then the hardness. Graphite is very hard, coal is also very hard. Okay, metal is very hard, right? But these two are exception, right? Graphite and coal are hard, sulfur and iodine are soft. Okay, so it is not hard. Okay, next one, malleability property. Malleability means all the metals can be drawn, most of the metal, not all metals, most of the metal can be beaten into sheets, right? But these non-metals will not be beaten into sheets. So all these are no. Okay, next, likewise metals can be drawn into a thin wire, that is called ductility property. But non-metals, most of the non-metals cannot be drawn into wire. Okay, then conductivity, electrical conductivity. Metals are, just now we are saying metals are good conductors of electricity. So non-metals are it is not a good conductors of electricity. Okay, except graphite. Graphite is a good conductor of electricity. Graphite is a good conductor of electricity. Sonority. Sonority is a sound producing property, right? So metals produce sound, whereas the non-metals does not produce sound. Okay, the graphite, coal, sulfur, iodine, it does not produce sound. Okay, so what is the conclusion from this activity 3.7? So we are seeing that with this physical properties alone, that means malleability, because we are seeing just now, we are seeing graphite is a good conductor of electricity, but it is a non-metal. Usually metals are good conductors of electricity. We have seen this graphite is an exception case, and iodine is lustrous in property, but it is a non-metal. Okay, you can see the by based on only the physical properties, we cannot come to a conclusion that it is a metal or non-metal, because so many exceptions are there. Okay, so we cannot group elements according to the physical properties alone, as there are many exceptions. Okay, so we'll see some of the exceptions. Okay, you know that metals are always most of the metals are solid at room temperature, but if you see the mercury, it is except mercury is liquid at the room temperature. Okay, and metals have high melting point, usually have high melting point. We have seen this activity 3.5. When you heat this wire, it will not melt, right? It has high melting point. But gallium and cesium have very low melting point. How can you say that very low melting point? Means if you hold that in your hand, in your palm, it will start melting. Okay, These two metals will melt if you keep them in your on a palm. Okay. Next, iodine is a non-metal, but it is lustrous in nature. Okay. And coming to the carbon part, carbon is a non-metal that can exist in different forms. Okay. Even in the activity 3.7, they asked us to take graphite or coal. Okay. So both are carbon only. Okay. So that we call it as allotropes. Each form is called allotrope. Okay. Graphite is one of diamond is one of the allotrope. It is a hardest natural substance. Okay, it is exception case. Okay, it is very hard in nature. Okay, hardest natural substance with a very high melting and boiling point. But it is a non-metal, but it has a very high melting point and a boiling point, and also hard in nature. Okay. Likewise, graphite is also a allotrope of carbon, but it is a good conductor of electricity. Usually non-metals are bad conductors of electricity, but this is the exception. Okay, like alkali metals like sodium, potassium, lithium are so soft. Usually the metals are hard, right? But alkali earth metals like sodium, potassium, lithium are so soft that can be cut with knife. So we can what is the conclusion from this is we cannot group elements according to the physical properties alone. Okay, by looking at the iodine we can because since it is lustrous, we cannot group them under the metal. Okay, some of the exceptions are there. So we cannot group the elements according to their physical properties alone, as there are many exceptions. Okay, next, activity 3.8. So activity 3.8, what does it say? Take a magnesium ribbon and some sulfur powder. Okay, burn the magnesium ribbon, collect the ash from formed and dissolve them in water. Okay, we are going to take a magnesium ribbon, going to burn that, collect the ash and then dissolve in the water. Test the result solution with both red litmus and blue litmus paper. Okay, and also same way we are going to burn okay, is the product formed on burning magnesium acidic or basic? We'll check with the paper, litmus paper. Okay, whether it is acidic in nature or basic in nature. Now burn sulfur powder, place a test tube over the burning sulfur to collect the fumes produced. Once you burn the sulfur, you will get a fume. So you are going to collect the fumes and add some water to the test tube and shake. Okay, this test this solution with blue litmus and red litmus paper. Is a product formed on burning sulfur is acidic or basic? Can you write the equation for these reactions? Okay, fine. Okay, so when you burn this magnesium ribbon and dissolve that ash in the water, you will get a magnesium hydroxide. Okay, magnesium hydroxide. It is basic in nature. Why? Because it turns the red litmus paper into blue. Okay, since it is basic in nature, that's why it turns the red litmus paper to blue. When you dip this blue litmus, there is no change at all. Okay, so since it is a basic, it turns the red litmus paper blue. Okay, likewise when the sulfur is burned and you can collect the gas sulfur dioxide form, and when you mix it with water, you will get the sulfurous acid. Okay, sulfurous acid H2SO3. It is acidic in nature. How you know that? It turns a blue litmus paper red. Okay, there is no reaction when you dip this red litmus. When you dip the blue litmus paper, it turns red. Okay, so they asked us to write in the equation form also. Okay, Mg plus O2, and burning it gives magnesium oxide. Okay, it is solid in nature. When this ash is mixed with water, you will get magnesium hydroxide. Okay, this is basic in nature. Okay, likewise sulfur, when it burn, you will get the sulfur dioxide gas, and this gas is passed through, when water is passed through the gas, you will get sulfurous acid H2SO3. Okay, this is acidic in nature. Okay, what is the conclusion from this activity? Most metals, what is this metal? Magnesium gives rise to basic oxide, right? Most metals gives rise to basic oxide when dissolved in water. Okay, and likewise most non-metal gives rise to acidic oxides when dissolved in water. metals gives rise to basic oxide, most of the metal, because some exception is always there. Okay, most of the metals gives rise to basic oxide and non-metals gives rise to acidic oxide. Okay, thank you.